All right, back again with another part of creating our own compiler and our own programming language. So what we have here, our programming language is called Hydrogen, and here's an example of its syntax here. So we can do mathematical expressions, assign them to variables, and then we can have an exit code which exits with the value of that variable. So in this case, if we evaluate this would be 2 times 3, which is 6. We then do 10 minus that value, which is 6. So then we get 4. And then we do 4 divided by 2, we should get a 2. And then we set y, but we just exit with x. So we should get a 2. So if we go ahead and compile this, we can run the Hydrogen compiler here. And then we have, actually I need to be in the CMake here. And then we're going to compile this test file, test.hy, and then now we can run it with .out, and then look at its exit code with the echo $? And then we get a 2, which is the correct answer. So that's the state of our compiler right now. Very simple. And if I bring up the grammar for this, all right, so this is our grammar for our language. So it's pretty simple. And our test program here pretty much covers everything in here. So I think what I want to do next is add scopes. All right. So if, in most C-like languages, most C-like languages have scopes. So where you can create a scope like this, and then you could say like let, you can have let y equals 69. And that's okay because once you end the scope, that variable is no longer there anymore. It's popped off the stack, and then we can reuse it over here, right? So you might be like, well, why are we doing this now? Well, because if we want to implement things like loops or control flow, they utilize scopes. So for example, an if statement, you have like if x is greater than 3, you have a scope. And if else, you have another scope. If you have a while loop, you have while true, you have a scope. And so scopes are used all over control flow. So if we want to implement control flow, we need to implement scopes. And I think this is actually a pretty easy problem to solve. If I go into draw.io here and get flashbanged, ooh, a new update, I don't care. Oh, look, there's some math that I was doing. So we have our stack, and we have some variables on the stack, right? So we have a variable here, we have a variable here, and we keep pushing them onto the stack. So we have like x, y, z, blah, blah, blah. But I think what happens here is, let's say right here, we have 3 variables on the stack, and then we open a scope. So we do like open curly brace. I think what we can do is we can keep track of where the scopes are opened right here, and then keep track of right where the scope is opened. And then any more variables that get pushed onto the stack are above this like opening scope place here. And then once the scope ends, all we need to do is just pop everything off the stack until we get to this point here where the scope was open. And then we're back where we started with the variables that are in the outer scope, right? So I think, and all these scope, like begin scope positions here on the stack, I think can just be represented as another stack. So we can keep track of them because you can nest these scopes, right? You can have something over here, and then you can have another one in here, and let z equals 420. All right, so you can nest them in here. So you can have an open scope here, declare a variable, you open scope, and as soon as you close this scope, we then pop all the variables off the stack that are until we get to this, where this position of this open scope was on the stack that we keep track of. Okay, we're getting complicated here. So let's actually just implement this, and I don't know why I minimized that. Okay, so in order to implement this, I think what we're going to do, I think we can actually do this during code generation, because that's where we keep track of our variables anyway. All right, yeah, so we have this variable struct here, which just keeps track of the stack location. So I think what we'll have is like a stack of indices for where the okay, we can't do indices because we have an unordered map. That's an issue. I forgot that we have an unordered map here. If we had like a vector, we could just keep track of the index of when the stack opens, and then we can do it that way. But this isn't going to work unless we, I think what we need is some kind of like, maybe we use an ordered map. Maybe. I don't know if I've used an ordered map in C++ before. What is it even called? Isn't it just called a map? Oh, do I have to like include it? Let's see. Include map. Okay, and then we can get rid of this one, right? So let's see. Maybe we can have an ordered map. Okay. And does everything still work, actually? I guess so, because I guess they have all the same roughly all the same methods. Okay, we have you messed up. Okay, well, we messed up because we changed our code here. But if we go back, okay, so everything seems to be, yeah, okay, so we can just straight up use a map. So this is now an ordered map, which means there's an order there that we can keep track of. So as things are pushed onto them, I believe it'll just push it onto the end. So when we do an insert on our map, is it just inserting at the end? I hope so. Maybe. So does that mean I can get like the index of it? Well, let's actually, before we even get there, let's actually modify our grammar so that we can support this. So how would this work? So I think what we can do, so we have our program, which is a list of statements. We have a list of statements. A scope isn't really a statement. Like, we could put it in statement here if we wanted to. I don't think that would make the most amount of sense. Well, yeah, I think it's the easiest way to do it right now. We can always refactor this later. So, under statement, we can have a curly right here. Or I guess this preview isn't updating. Preview, open preview. Is this one gonna update now? No? Oh, is it because it's like a LaTeX thing? Do I have to escape them? Oh, okay. Maybe I don't have, wait, do I have to? I guess I do. Okay, so I have to escape those. And then we just have like a list of statements in here, right? Kind of like this. Oops. Like that. So a scope is a statement itself that contains a list of statements. Maybe not the biggest fan of that, but we'll just do it because I think that'll be the easiest way to do that. So we need to introduce these tokens first, right, in our tokenizer. So if we go to our tokenizer, also, you know what? Someone commented saying that I should rename some of these. This one, instead of sub, have it be minus, which would be this symbol, and then div should be slash instead of div. I agree with those changes, but you know what? Can CLion just fix these for me? Can I just do minus and then just do, let's do f slash for forward slash in case we do a backslash. And is that just gonna like, did that just do it? Like, is that fine? Instruction expected. So apparently that didn't change it everywhere. So I'm just gonna undo that. And we'll fix that later, I guess, manually. Okay, because that did not work. So, okay, but we need to add an open curly, close curly, format. Beautiful. Now we need to actually add these here. So we can do else if peak.value equals curly Oops. I'm messing everything up. And we can consume it. Tokens, pushback. Type, token type. Open curly. All right. We can just copy and paste this. And this will be close curly. Okay. So, cool. Now we need to change our parser. So what we changed here is our statement. So our statement can also have a scope. So in here we can have a node statement scope. And then we need to actually create that. So struct node statement scope. And this is just going to be implemented as a vector of statements in there. I think we're going to have to forward declare this. All right. Cool. If I build this, I don't think it'll build now. Yeah, because we're not matching all of our types in our variant here in this file. All right. Okay, so we're now here. So we need to handle the scope. So let's handle that. Node statement scope. Let's just call it scope. Cool. And let's just assert. Well, I don't know if I want to assert now. We could just implement this right now. But we need a way of beginning our scope and ending our scope. So first of all, on our map here, since this is ordered, if I take the size of it and I subtract 1, is that the index of the last element that was added to it, the last pair? I wonder. So if I do mvars dot at, so there's a dot at there, but can I like just go to a certain index? Because it's ordered, right? Or is this not like how I think it is? So can I like get it at the second position? Maybe this isn't going to quite work for, you know, I think to keep things simpler for now, I think instead of a map, maybe there's a way. C++ map get pair at index. Is there a way to do that? Oh my goodness, my eyes. You have to have like an iterator. Okay. That's I might be able to do that because you should be able to then get I should be able to take the last, right? So if I do mvars dot, how do I get the iterator of it? I don't even remember. Oh, well, I just do end. So end. Yeah, and then I can get the first and second here. But end is one past the end, which is one past the element because this is C++, and that's how that works. So it looked like they used standard advance. I didn't even know that was a thing. So you can do that. So then I need to go back one. Like that. Is that like acceptable? This isn't even, no matching function. Expects an L value. Oh, I have to like create, this is horrible. You know what? I think I'm going to do this a simpler way, which isn't going to be as, I guess, performant, but it'll be simpler, I think. And that is to just have a vector of a, and then our var, we can put a string that is the name of it. And we can just have a var and just do vars like this. So it's just a vector. We're just gonna break a few things. And then instead of having contains, we just do find, like the standard find. So we can do if not gen, or if gen mvars dot, we do standard find. And we do like dot begin, cBegin, essentially passing the iterator to it, cEnd, and then I'm lost in my parentheses. And then we're looking for, oh, what are we doing? I need a lambda, right? So like that. I feel like my parentheses aren't quite lined up. No, it's fine. And then we have const var. What is the problem here? Return var dot name equals this. What does this return if it can't find it? What does this return? Oh, it returns like the last one. So if it doesn't, so I'm checking if it does contain it. So if it doesn't equal gen mvars dot end, what is the issue? Oh, because I need to like do this. And what is the problem now? Okay, I need to do find if. That's how, because I need to access. I see. So const var. Oh boy, that broke a lot of things. And then I need to do return var.name equals this. There we go. So we're finding if this equals this, and as long as if it doesn't equal the end, then that means it contains it. And then, or is it the other way around? We want it to contain it. Right. So if it equals the end, then we don't want that. Okay, so we need to do it like that. And then we need to find it in here. So instead of at, we need to do actually, you know what? We can take this. We can take this, and then we could do auto it equals this. So it's like an iterator. And we could say if iterator equals gen mvars. If it equals the end, then it doesn't exist. Else, it does exist. Well, we don't need an else because we exit here. So then we can just dereference the iterator, right? So we could do iterator. We can dereference it. And then we can take, and what are we trying to get here? Oh, I guess just that, right? Okay. So instead of using var, we can just use this. We dereference the iterator. Okay, so that clears that up. And this is pretty much the same thing. So I'm actually going to copy that, find if from before, go here, and then if the iterator, and this time we want to see if it's already used. So if it doesn't equal the end, mvars cEnd, then if it doesn't equal the end, then it already exists. Cool. We need to change that out. And then instead of doing insert, we just push back. And then we do dot name equals this, and then dot stack location equals that. All right. So let's just do sanity check. Everything should still work. It does still work. Cool. And then now we can create our scopes. So we can have a vector with, which is just a, what's the size? Size t. And this is just going to be scopes. Right, and these are just going to be indexes or indices into the variables array or vector, stack, whatever you want to call it. Okay, so when we begin our scope, we want to begin the scope. So let's have a begin scope, and then let's have an end scope. And these will be functions on our, these will be methods on our generator. So we'll do that. And then we just need to do, we need to go through all of the statements and then parse all the statements. So we do for, this should just be a const node statement in scope dot statements, and then we just do gen statement and then pass in the statement, right, like that. So let's create this begin scope and end scope, and these are supposed to be private here. So we'll do void begin scope, void end scope. So begin scope, what we will do is we just do mscopes dot push back mvars dot size. Okay. Maybe we need to subtract 1. Do we need to? No, I don't think so. We might be having off by 1, but those we can deal with. We can debug. So then we end the scope. And when we end the scope, we want to pop off all the variables in here until we want to pop off variables until we get to the last begin scope in here. So how do we do that? So first let's determine how many variables are in, so we can, in order to determine how many variables we need to pop off. So let's just do a quick count. Let's call this the pop count. All right, because this is how many variables we're popping off, and that's just going to be mvars dot size minus mscopes dot back. So the very last one, right? And what does it not like here? Unsigned long to, okay, so maybe we need to make this size t. Maybe that'll satisfy it. Okay, so we have our pop count, and so now we need to move the stack pointer in our assembly back, right? So that way we, that's essentially how we pop off the stack in the assembly. We just move the stack pointer. So in order to do that, we need to have our output, and we're not popping it into anything, so I don't think we don't need to modify, we don't need to use this pop here, because we're not popping into a register. We just need to make sure that we subtract our stack size as well. So we have our pop count, and then 1, 2, 3, 4, we need to do RSP. Well, we need to subtract from RSP, right? So we need to do sub from RSP, and we need to subtract our pop count, right? Like that. Actually, I don't think I used end line. I think I'm just using new lines like that. Is it subtracting though? I need to make sure, because the stack is upside down. We actually need to add to it. We need to add to our stack pointer, because the stack grows from the top, so adding is like popping off of it. So we add to our stack pointer, pop count, but each of our variables is 8 bytes because we're just using 64-bit integers. So that's our only type. So we need to actually multiply that by 8. And then we need to subtract from our stack size, which our stack size is not being counted in bytes, it's being counted as 64-bit integers. So we need to do minus equals pop count, like that. And then the last thing we need to do is get rid of all these variables in here, actually. So we just need to, what's the best way to do this? I guess we could just do a for loop. We just do int I equals 0, I is less than pop count, I plus plus, and then we can do mvars dot pop back. And then we need to actually get rid of our last scope. So we do mscopes dot pop back. Okay. So I see a lot of potential for things going wrong here because of off-byte ones, but let's just see what happens, right? Let's just see what happens. You know what? I think I'm going to make the same mistake as I did before. I created the statement scope in here, but I didn't actually parse it. So we actually do need to find where we parse our statement. Yeah, and then we need to add else if, and then how did we do this? We had like a new, like some different functions I added that can help with this. Is it like try consume or something? Else if auto, like, is it like open curly equals try consume? Yeah, and we don't want an error message. Open curly and then token type open curly, right? So if it was able to consume it, then we can use it. Otherwise, it just continues down here. So then what we can do is we can create our node statement scope, but we could just do that as auto. So it's auto scope equals, and then we can use our allocator, allocate node statement scope. We can do scope dot statements. Okay, so that's how we can do that. In order to parse our statements, how do we actually even? I think we do that somewhere over here. Yeah, while peak dot has value, we parse statements. Okay, so we create our scope. So I think what we're going to have to do is if auto statement equals parse statement. So if we're able to parse the statement, then we do scope dot, so this is actually while. While we can parse it, scope.statements dot push back the statement. Right. And it doesn't like that. Did I screw something up? Ah, we need to do dot value here. Right. And then if we're not, as soon as we're not able to parse any more statements, we should have a closing curly, right? So we should be able to do try consume token type close curly. Otherwise we have an error message. We should put expected close curly. And then just return. Well, we need to actually, we need to create a statement. So we need to allocate a node statement, and then statement var equals our scope, and then we can return the statement. Okay, that should do it. So everything still works here. Let's try and do our scope. So if I do a let y equals x, let y equals 2, okay, so that actually worked. Cool. Yeah. So because if it wasn't in the scope, if we put it down there, yeah, identifier already used y, but because it's in its own scope, it's fine. But if we have like this, we have let y equals 69, we can't do that because it's in an outer scope, right? Yeah. I guess that would be like shadowing, I think it's called, when you have like a local variable, the same name as an outer variable, you shadow it. So I believe this is actually allowed in C++ and in C. But, right? Is it allowed? I feel like that's like a thing you can do. You can shadow variables, unless I'm not thinking properly. So if I have like an int x equals 27, 26, sure. And then I can say int x equals 36. Yeah, so you can do that. It's just saying that it's, yeah, shadow is a local variable. So we're actually like disallowing shadowing. We could change it to allow shadowing. I don't know. Let's not allow shadowing for now. Because, I mean, when I did it in here, CLion gave me a warning saying that I'm shadowing, right? So it seems like it's not a very good thing to do, right? I mean, that's honestly a little confusing, using the same name just in different scopes. So maybe we don't allow shadowing for now. And if in the future I think we should allow shadowing, then we can change it. So if we go to our assembly here and see how this is actually working. So let's actually make something that actually does work though. So let's just have a Z here so that we can compile it and then run it. Oh, and another thing is that we should, if we try and exit with Z here, that shouldn't work, right? Because it's in this inner scope. Yes. But if I exit with Z here, it should work. Whoa. It doesn't. Ooh. Oh, well, because we're trying to use it down here. So that might be why. Yes. Okay, so that does work. So if this does this exit with 69? Okay, it does. So cool. So if we look for where we add to RSP, there we go. So these are like our, okay, there's an extra new line in here somewhere. It's anytime there's a push. I seem to have added an extra on the push, added an extra end line somewhere. And I don't know where. So it's not here. So it must be when I'm calling push. Did I like, where is that happening? I don't know, but it's somewhere it's adding a new line and I'm not sure where it's coming from. Is it this? Ah, there is a new line in here. There shouldn't be a new line in there. So that should fix that. There we go. Okay. So add RSP. These are like our two pops here. Or two of our end scopes. It's a little late, okay? I'm like, I can't think properly. So if we go to our code here, if we decide to do a few more variables. Oh, well, we can't do that because it's going to not allow it. But if we do something like that, let's actually put it in here. So that way we can watch it pop them off the stack. Actually, yeah. So we can do that. We go to our assembly. We're putting all these 69s here, and then we can see, yeah, there we go. We have, like, I guess there's 5 variables. So it will move the stack pointer 40. Essentially, because the memory for the stack is already allocated. All right, it's already allocated. So the stack is essentially just like already there. It's just a matter of putting values in it. And so to pop off the stack, you have there's a pointer that points to the top of the stack. Like right here. So what you essentially do is just move it back here and say, okay, the top of the stack is here. And that'll allow you to, whenever you push new values, you're just going to overwrite the existing values that are there. So it's kind of like deleting a file. If you know that like deleting a file is it doesn't actually like zero out the bytes on your hard drive or your SSD because that's like expensive, right, in terms of performance, and it's just not necessary. So all it does is the file system, the operating system, just marks that area of memory as free, but it doesn't actually delete the data. it just marks it as free, so that way when you create a new file, it can just overwrite it. So that's why there's tools that can like extract the deleted files if they haven't been overwritten yet, right? So that's essentially what's happening here, is that we're just moving the stack pointer. So essentially we're popping these out the stack by just like marking them as like outside of the stack that we're using, right? Like we'll never be able to access those beyond the stack unless that's like, I don't know, some kind of undefined behavior, because you shouldn't have anything above the top of the stack pointer, right? That doesn't make sense. If you have a pointer that points to the top of the stack, you can't have something on top of the top, right? You just don't do that. Okay, so we have scopes. That's pretty cool. So I guess what we can try and do is maybe add an if statement. Is it a statement? I don't know. A statement, control flow, whatever. I don't know what things are anymore. We're not going to try and categorize these things. But I think it would be cool to have an if statement. Also, we should definitely write tests. So a lot of people talked about tests. I totally agree. We should have tests. We will get to it. One of the things for our if statements is I don't know if I want to require parentheses or not. All right, like should I just be able to do X like that? Should I just be able to do that? Or should I require the parentheses? There's a part of me that just kind of likes the parentheses because it like groups things together really nicely. It doesn't really change the parsing at all, I don't think. But I kind of like the parentheses. Right? Like that just looks more readable than this. And that's just personal preference, I guess. Technically it's more symbols, but you know, it's kind of like the if kind of blends into this whole thing, and I don't know. I kind of like the parentheses there. All right, and this is all about personal preference. So if you don't like it, I don't care. Fork it and do what you want. All right, I don't really care. You can do what you want. It's open source, free and open source, so you can do what you want with MIT license. You can do what you want with it. So I think I'm gonna have the parentheses. All right, and then we have a scope here. So. Okay, so I think we can add that. So if x is greater than 1, we can exit with 69. Otherwise, we will just exit with 1. All right, we don't even need to have an else right now because this exit, it'll just exit, it won't do this one. So we also don't have a greater than. So that's something we need to do. So maybe we just do if x for now. And then if it's anything other than 0, it's considered true. So we can just do that. So that'll be good. So we won't have booleans yet because we don't have types. What we can just do is just do, you know, make booleans, just, you know, 0 is false and anything other than 0 is true. So we could just do that. So let's go to our grammar and see how we can implement this. So I think this will be a statement. And we'll have an if keyword, right? So we'll have an if, and we need a new line here, right? Yeah, we need to do that. So we can have an if, and then we have parentheses, okay? And then in our parentheses, we have an expression, right? So any kind of expression in here, and we put those in square brackets. So if expression, and then we have a scope, right? So that makes me think maybe we should just have a separate production for a scope, because this is essentially just another scope in here. So maybe we should actually do that. Maybe we should have a scope, and then our scope is just this, like that. And so we can have a scope in here. And then we can have a scope over here. Like that. There we go. So we can kind of like reuse that. Okay. And then so our scope is a, we have these curly braces here. So yeah, okay, so that should work. Okay, that should be enough for our grammar. So a few things here we need to change. So because I changed that for our grammar, it's no longer, it's like its own thing. So we should have a struct for a node scope, which is the vector of statements, and then the statement scope is just, well, it can just, we don't need this anymore. Oops, that's the wrong thing. We don't need this. This can just be a node scope, right? Okay, so I just renamed something. I don't know, what did I even just do? I just like mixed some things around, which when basically I just renamed something. I don't even know what just happened there. Okay. Nice. Did that break anything else? Yeah. I need to rename these here. I could have just done ask CLion to rename all that for me. That was really strange. Invalid statement. Oh boy. Invalid statement. What did I do? Oh, because I like changed all that. I keep forgetting I do that. Okay, so we need to have an if token. So let's go ahead and do that. Let's create our if token. And that's a keyword. So that means we need to escape that. And I believe, how did I escape the other ones? Oh yeah, we used to have a return. I think we just did an underscore. Did we do an underscore for? No, I think we did an underscore second. Yeah, so we could just do that. So if we have an open parenthesis, we have a closed parenthesis, we have our scope. So that should be the only one we need. And so in here, that'll be under our keyword tokenizing here. So in here, we'll have an if, else if our buffer equals if, then we can push back an if. All right. Now for our parser, we need to create a node statement if, and that will contain essentially just a scope, right? Well, the expression and the scope. So we need the expression. So node expression and then node scope, just like that. And then our statement will go ahead and take node statement if. That needs to be a pointer. Okay. That breaks there. Cool, because our visitor now has another option. Node statement if. We could just do if. Let's do statement if like that. And we will just do assert, and someone told me in the comments I could just do false, and then this, so I can do not implemented. And then it will actually it'll actually show this message to me when the assert is false. I didn't actually test that. I assume the commenter is right. So okay, but we have an invalid statement because we need to fix our parser now. So under parse statement, we need to go to here. Okay, so we need to do else if auto if equals try consume token type if. So if we're able to consume an if, then we also actually we want to try and consume a couple things. Actually, maybe not. No. We just need an open parenthesis now. So we can say consume. Well, we'll do a try consume. So we expect an open parenthesis. Token type open paren. Otherwise, we expected an open paren. And then we just need to parse the expression. So if auto expression equals parse expression. Oops. Then we can go ahead, we actually need to allocate our statement if. statement if equals mallocator.allocate node statement if node statement if, and then statement if dot expression equals expression dot value. That needs to be an arrow. Else, did I have a? I don't think I had a utility function that could do this for me. We should probably do that. Just like we have our try consume, I think a try parse would make sense too. But for now, we'll just do that. And then after we parse our expression, we need to look for a close parenthesis. And then we need to parse the scope. So if auto scope equals parse scope. Oh, we don't have a parse scope. We don't have it. Okay, that's what we need to do. So yeah. So we need to have our own spot for a node scope. Optional node scope. Parse scope. And we do well, we need to first check if we can try consume token type open curly. So if we can consume it successfully, then we can do all this stuff. Otherwise, we return nothing. And then we want to return the scope. So then when we have open curly, so we're not consuming it here. We just want to do if peak dot has value and peak dot value equals dot type equals token type open curly. Then we can just do parse scope. If auto scope equals parse scope, then we can do this. And we have a problem here. Scope.value. Else, we say that it's an invalid scope. All right. And then over here we can do our parse scope. So if scope, then we can take our statement if scope equals scope.value. Otherwise, we need to say we can just say expected scope, or it's invalid scope, I guess. Throw out a semicolon. Okay. We need to allocate a statement. I'm too lazy, I'm just gonna do that. And then var equals statement if. Return statement. Okay. Yeah, assertion false, not implemented. Okay, yeah, it just prints out the whole thing. That's fair. Okay, so we got to our search. So it parsed it correctly. Now we just need to implement it. Right, so how are we going to do that? How are we going to do that? How do we create an if in assembly? Well, I guess the way that it would happen is that we check if this is if it's not 0. Well, I guess if it is 0, then we need to jump over this entire code to here. Otherwise, we just execute this code. So I think in the assembly, we essentially have like a label here. We need to create a label here that we can jump to if this is false. Right. So we need a jump instruction here. So I believe if we look up x86 64 assembly or like NAS assembly jump instruction, jump quick reference. I know it's gonna be a light mode. I just know it. Oh boy. There we go. So jump if not equal or if not 0. So jump if not 0. Can I like invert that? Because we're going to jump if it's not equal to 0. Or jump if 0. That's what I want. Jump if 0. So we're going to jump over the scope if it's 0. So that's what we want to use. JZ. And then how do we use that? How do we use that in assembly? So you give it JZ and then I guess the register? I guess. Oh, and then you need to give it like the label to jump to. Right, so we need to create a label then. So we need a way of creating labels. And so if you don't know in assembly, I guess the way, maybe I should write out what we're doing here. Okay, there's nothing in our assembly here. So a label is just like, you can create like a label 1, label 2. And so essentially what will happen is this would be like our if statement up here. So we have our if. So if jump if 0, and then we have the result of our expression in racks, and then we jump to label 2. I just need to figure out how to actually do that. So JZ NASM example. I just need an example of how to do that because I can't quite remember how to give it the label. How do you just use it, right? Like I just want a simple example. Ooh, you have to like compare them first or something. Test if EAX is 0. Okay, so we have to like test if racks, I don't know why we have to put it twice. Apparently we do. Test if EAX is 0. So we test it, and then if it's 0, we give it the label. There we go. Otherwise, this is like the inside of our if statement. We have add, blah, 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 blah. We have all of our stuff in here. I guess these are comments in assembly. Otherwise, this is the end of it. But if it's not 0, and it's true, it'll execute this, and then it'll automatically go past here into the rest of our program. So this is essentially if here. So we need a way of creating labels. And I think we could just call it label and then a number that just increments. So we can go ahead and do like maybe create label. And we give it a string, and we have like a label count. So we can have like an int m label count equals 0. And then we just do return what is the right way to do like string concatenation? I guess we could just do like label plus, I just do like m label count. Can I just like string like that? Is that like not fine? Yeah, I can't convert it to it. Like how? I can't just give it. I gotta be honest, I don't know how to format things correctly. Can I use, is this usable now? Can I use standard format? Is that like a thing that is like, I know I've heard about this, but I don't know if I can like use it. Does it work? I don't have it. I thought it was a thing, but I don't know. Yeah, see, like define in format. Okay, well let's try and include it. I think I remember trying to use it before, but for some reason, like the compiler just really did not like that. Yeah, format not found. So I don't have a format, so that's really annoying. So this whole string concatenation is an absolute pain. Okay, I don't know how to do it correctly. I guess I could use like printf, sprintf or something. I'm gonna do it the way that I know everyone's gonna get mad at me for, but it's how I'm gonna do it, which is ss label and then do m label count plus plus and then just return ss.string. Okay, yeah, I know everyone's gonna yell at me. Okay, it's inefficient, it's wasting CPU cycles, it's horrible. Okay, the whole thing is garbage. Okay, it's bloated. It's bloated. All right, I can already smell the comments. All right, but guess what? You know what you smell though? Me not caring. Okay, I don't care. So, okay. What was I even doing? We need to. Okay, we're at our assert. We are at our assert. So, first statement if. We need to evaluate our expression. Right. So we need to evaluate our expression first. So we do gen expression, our expression. So now after this, what this will do is it will put the result of our expression on the top of the stack. We now need to pop that into racks, right? So we need to do gen pop into racks. So now the result of our expression is in racks. And if it's 0, we need to jump. But we don't know where to jump to. We need the label. So let's create the label. Like, let's get the label. No, we're just getting, we're not putting it in our assembly yet, right? Because we need to actually put the label after. Did I get rid of all that? Okay. We need to put the label after here, right? But we can still just save the string value of it as a variable before we output it. So let's go ahead and have our label here. So let's call it, I don't know, label equals create label. And this needs to be gen. So we create our label. We need to do that test, right? So we need to do, what is it? 1, 2, 3, 4. Test racks against racks or something like that. So we test it. And then the result of that, we determine it by doing this like jump if 0 to our label. And then we generate our scope. Gen scope. We don't have a gen scope. We need to do that as well. Oh, jeez. Okay, we have our scope here. We need to put this in its own gen scope. Const node scope. Scope. Yeah, this needs to be a pointer. Scope. Oops. All right. This doesn't need to have gen because it's not in the visitor. All right. And then in here we just do gen scope. Just kidding. Gen scope. Scope. Oh my goodness. Okay. What is this? Okay. We generate our scope using our statement if our scope here, and then after that, then we can finally put our label. we can put in our label, put in our label, colon, and a new line. Okay. Does that work? All right, what do we have here? We have 69. So let's just make this 0 then. We don't have comments. I can't comment this out. So I think I'm going to duplicate it and then just change the name. So that'll be y, and then x will be equal to 0. So then this is going to be false, so it'll just exit with 1. Oh my god, that just worked. We have if statements. What? Let's actually look at our assembly. Let's see if it's formatted even correctly. Oh, look at that. So, okay. So if we look here, where's our actual expression? So we pop racks. Our expression is just x. Maybe we can do this a little bit more, and maybe we can make the expression a little bit more interesting. So we can do if x plus 1. So now this should just return 69. But if we make this -1, it'll add 1, and which would be 0, which would be false. So then we should get back to 1. You know what? We don't have negatives. I didn't even realize that. Oops. All right, so we'll do -1 and we'll make this 1. All right, we need negative numbers. Oops, I did not think about that. Okay, so we have 1. Boy, we don't have negative numbers, we have if statements. My priorities are all over the place. So that works. Okay, so that's a more interesting expression there. So we... where's the subtraction? Okay, so here we are. So we have pop racks, pop rbx. So this is where we have the value of x and the value of this 1 here, I guess. Right? Yeah, something like that. And then we subtract them, and we push it back on the stack, which will immediately pop it off. Oh yeah, I know this is very optimized assembly. All right, but we're just getting things working, guys, okay? Then we test it, and we say jump if 0. In this case, it is 0, so it jumps. So it jumps to label 0, which is over here. So it jumps over all this code, which is where it exits with 69, right? We jumped over it to this. Otherwise, it would just run this and then run this. We can actually maybe test that, right? We don't have to exit. What we can do x. Oh, we don't have reassignment, do we? Oh my goodness, we are like... I need to make more videos because I was gonna say like maybe I could do like x equals like plus equals 1 or x equals x plus 1. So, and then exit with x or something. So like I can actually see the value changing, but I can't do that because we don't have reassignment. Yeah, we can't do that. Oh my goodness. All right, that'll be definitely next. But I think everything's working. Like things seem to be working fine. We should definitely write tests. But I think since we're at the end of the video, roughly, well, end of what I wanted to do. It's not the end of the video yet, guys. Hold on. Let's do some refactoring. Okay, I think that's a good next step. So anywhere I have this sub, I want to be minus, right? So I'm just gonna do like what's the replace? How do I replace it? There we go. So let's take sub and make it minus, right? Replace all, and let's see, is anywhere else use sub? Okay, you know what? Okay, what we'll do, let's try it with this sub minus. And why doesn't this work? Yeah, so minus inconsistently redefined. So something is just absolutely not liking that. So let's just do sub to minus, and let's just replace it as we come across it, because something's just not right here. So let's find the next. Oh, it's replacing the instruction here, isn't it? Oh, it's replacing this too. So we need to replace this one. Wait, no, we don't even need to replace that one. What am I even talking about? We don't need to do that. So this is all fine. Is that just it? Okay. Maybe this is how I should do it. I should just find the compile warnings and just do that. Okay. Hello. There we go. All right. So that's changed. Now let's change div to /. And then find the compile warnings or errors. Anywhere else? Over here. /. Build. Warning here. I didn't type it right. Over here. /. Okay. Cool. That's all working. Okay. So that's one thing. Another thing I wanted to do was taking a look at our visitors here in our code generator. And what I wanted to do is someone said I should make this a reference, which actually makes sense. I don't know why I don't make it a reference. This should be a reference, right? I think that would actually make sense. So then what we could do is we just set it to the dereference of this. And then all of these arrows become dots. And that way, that can ensure that it's not null, right? Because before, we could just set it to null. Like, we could forget to set this gen here. And it wouldn't do, null checking for us. It wouldn't let us know. So this should just be a reference. I don't know why I didn't do that. Just an oversight, I guess. I was just feeling in the pointer mood at that point in time. Can I just do that? Okay. That'll just be easier. I wonder if there's a keyboard shortcut to jump to the next error. To like the next squiggly. Maybe. And then let's look for generator star. Okay, make that like that. We can take this. Change that. Cool, cool. Change that one. Oh boy, we got a whole bunch of them here. A whole gaggle of arrow. A whole gaggle of arrows. That's what a group of arrows is called. It's called a gaggle. Did you guys know that? Well, now you know. Okay. Okay. So generator. Ooh, star. We have another one. Just more of this. I guess the reason I put this refactoring at the end of the video is because I feel like most people don't care about this. So if you just wanted to come for the main topic and that's it, then you're probably gone by now. But for the hardcores of you weird people, you're still here, and I don't know why. Okay, so do we have any more generator star? No. Beautiful. So let's run this. Nothing should have changed. Okay. I genuinely can't remember if I looked at any more comments. I mean, I read all the comments. Okay, I read all the comments. I can't think of any more other suggestions that people suggested other than saying my code is bad, which, by the way, doesn't help. It's not a helpful comment, but I mean, I don't care, but it just doesn't like do anything. It's just completely useless. So if you want to suggest something, I'm totally up for it, you know? Just say, you know, be specific, and if I think it's a good idea, I'll change it, right? Like, I think that's a good way of doing it. Like, I know people told me I should use standard format, but I can't, and I don't know why. What am I using? Am I using GCC? I am using GCC because I'm in WSL, right? Like, does this version of GCC not support format? Is that what it is? I could look it up myself, but I'm sure the comments will tell me based on this. All right, so I think that'll be it for today. We have if statements, we have scopes, but there's a whole lot of stuff missing, and maybe it's time that I should actually make a list of things that I really need to do, like unary operators, like being able to do negative values. That would be good. And then reassignment, right? So I can do x equals x plus 1, or just reassigning it to anything. I can't do that right now, right? That's just not acceptable. All right, well, that'll be it for this video. I will see you guys in the next one.